Let's take a look at example 4 from section 11. In this example, we're now going to do some trigonometric factoring, just like the algebraic factoring we did in the previous example. In this example, I can tell that this equation is, we verbalize this as being quadratic in sign, and that is because our first term involving x is squared. Our second term involving x, we have one copy, it's to the first power. Our third term involving x, well, we don't have any x in there. There is no x. So I have a squared, a first power, and a zero power of x. There's two of them, there's one of them, there's none of them. This is how I can identify that we are generally in some sort of quadratic format. The only difference is that we, instead of having x's, we have sine of x. And so everywhere in our previous algebraic factoring problems where there was an x, we will now have a sine of x instead. We're looking for general solutions here, not just in any specified interval. But since I'm recognizing that we're quadratic here, I'm going to go ahead and use my quadratic factoring techniques. I'm going to make my product pair list for -7. Let's talk through what we should expect here. If I'm going to multiply two numbers together to give me -7, it must be that one number is positive and one number is negative. The only way you multiply two numbers and get a negative is if one's positive, one's negative. So I'm looking for a positive number and a negative number. Further, I know that when I add them together, I need to get +6. This tells me that when I add them together, it needs to be the case that the larger of the two numbers is the positive, the smaller of the two numbers is the negative. So I'm going to make a product pair list for -7. Each of the pairs is going to have one positive number and one negative number. And because this number is positive, I know that I'm looking for my positive number to be the larger of the two. Well, that was a whole bunch of me talking just to be able to write the only one pair that exists for -7 here. The only way that I know to multiply two numbers to get 7 is with 7 and 1. But as we agreed, there's going to be one positive, one negative, and the larger of the two is the positive, so that means the smaller of the two is going to be the negative. So it looks like my only choice here is the 7 and -1. And the good news for us is that these do multiply to -7. These do add together to give +6. So it looks like this is going to be a reasonable product pair for us here. So as I said a second ago, everywhere there used to be x in our factored forms, there's now going to be sine of x because we are quadratic in sign, not just quadratic in x. So here it looks like we can factor this as sine of x plus 7 times sine of x minus 1. Again, now that we are factored, we can go ahead and use our zero product property to say if two numbers are multiplied together to give 0, then either the first number is 0 or the second number is 0. So I can ask myself, sine x plus 7 equals 0. What value of x makes this true? Well, if I subtract 7 from both sides, then I get to the equation sine of x equals -7. This is saying to me, what angle results in a height of -7 on the unit circle? What does unit mean? It means of radius 1. So if I'm really looking for a solution for this guy on my unit circle, this is a height of -1. We are interested in a height of -7, which is going to be somewhere way down here. It doesn't seem like there's going to be actually any angles that are going to provide for me a height of -7. What we know is we know that the span, the heights of this guy, are always going to go from -1 to 1. All outputs from sine and from cosine always live between -1 and 1. Therefore, it's impossible for us to get an output from sine that's outside of the span from -1 to 1. So it doesn't look like there's any value of x that makes this true. It looks like this branch of our solutions provided us no solution at all. There isn't a value of x that's ever going to cause this to be equal to 0. On the other hand, over here, we could look at our second equation. Either this is equal to 0 or this is equal to 0 to make their product equal 0. So we could now say, alternatively, it should be the case that sine of x minus 1 is 0. To help me solve this equation, I want to get the x terms as alone as I can. So I'm going to write this as sine of x equals 1. This is asking me the question, what angles result in a height of +1 on the unit circle? When I draw my unit circle, I think to myself, I want to get to a height of +1. There's only one angle that's going to get me to that height of +1. I'm picturing that guy right there. This is located at pi halves. And since I'm looking for the general solution, not just my solution in 0 to 2 pi, I'm now picturing to myself, well, when will this happen again? Well, one of our solutions happened at pi halves. The next time we're going to get another solution is when we've done another full rotation around, and then another full rotation, and then another full rotation. So how do I indicate all possible additional full rotations? We're just going to stick on a plus 2 pi k. This says, plus you can do an additional full revolution as many times as you want, as long as these are all going to land back on that angle that's coterminal with pi halves. So it looks like in this case, one of our parts of our quadratic provided us no solutions. The other part of our quadratic provided us the general solution of pi halves plus 2 pi k.